In this video, we're going to talk about using a sine ratio of a specific sine function, y equals sine theta over theta, to find limits for trig functions. So in this situation, we're looking at this graph, and this graph is, not to scale, but it's drawn out so we can see what's going on here. And looking at this graph, we can very easily see that the limit as theta approaches 0 of this function, sine theta over theta, equals 1. And this limit can be found or proved using the sandwich theorem, but for now I'm just going to ask you to trust me and believe it. Okay, so this limit that I have just written here, this is something that we want to make sure that we know and that we're going to use in the coming examples. So let's do an example with this. In this example, we're going to find the limit as t approaches 0 of 2t divided by tan t. And what we want to make sure that we remember, what we defined on the last page, is we're going to say that the limit, as I'm going to use t instead of theta, as t approaches 0, t over t equals 1. All right, so this is something that we know and we want to use. And we need to somehow manipulate the given limit so that we see that ratio, sine t over t, hiding in there. Because if I can find that, then I can use my definition or my theorem to turn that term into 1. All right, so looking at this limit, obviously when we're dealing with a limit, we try to plug a value in. In this case, we would say, well, let's evaluate that. That would be 2 times 0 over tangent of 0, which gives us 0 over 0, which is not defined. You can't have 0 in the denominator. This is actually what we call an indeterminate form, and we talk about that later in the semester. So since I can't evaluate my limit, I need to manipulate it. And in this situation, I'm going to write it in a way so that it looks factored. 2t times 1 over tangent t. Now remember, tangent, 1 over tangent, that tangent's reciprocal to cotangent. So I can rewrite this and say, well, that's the same as 2t times cotangent of t. Now, if I try to rewrite cotangent as sine and cosine, I know that tangent is sine over cosine. So cotangent is cosine over sine. So limit of, as t approaches 0 of 2t times cosine t over sine t. All right, so let's manipulate this a little further. So using properties of commutativity for multiplication, I can rearrange the way this looks and say, well, that's 2 times cosine of t times t over sine t. And notice this is pretty similar to that, but not exactly the same yet. Good thing is that I know division by a fraction is multiplication by the reciprocal, or multiplication is division by the reciprocal, right? We have that reciprocal relationship here. So this next line, I can say, well, this is the limit as t approaches 0 of 2 times the cosine of t times 1 over, and so I'm going to take the reciprocal of that, which is going to be sine t over t. You see that showing up now in the denominator, and I flipped it. So the limit of a product is the product of the limits. And at this point, we could take the limit of each of these terms. So evaluating this, this would be 2 times the limit as t goes to 0 of cosine t times the limit as t goes to 0 of 1 over the limit as t goes to 0 of sine t over t. So if I plug 0 into cosine t, I have 2. That would be times the cosine of 0. The cosine of 0 is 1. The limit of a constant is the number itself. And then this piece in the denominator here, we know this limit because that is something we define. That's a theorem we have that we're going to be able to use. So I know that's equal to 1. So now I can say here that this limit is equal to 2 times 1 over 1, and multiplying by 1 keeps it the same. So the limit as t approaches 0 of 2t over tangent t is equal to 2. And again, the whole goal in this problem in using this rule was to be able to manipulate what I was looking at so that I formed this sine t over t, and we're looking at it as it goes to 0. And of course, we knew that would be equal to 1. So let's look at another example of using this rule to solve a trig limit. So again here, we are going to find a trig limit. This is the limit as x goes to 0 of 6x squared times cotangent x times cosecant of 2x. Remember, what we know is that the limit as x goes to 0 of sine x over x, that is going to be equal to 1. So at this point, we begin to get creative with our manipulation. We're trying to figure out how to develop sine x over x. So I've got the limit as x goes to 0. Now, 6x squared, I can factor that, and I could rewrite that as 2x times 3 times x. Cotangent x is cosine x over sine x, and cosecant 2x, right? Cosecant 2x, cosecant is reciprocal to sine, so this is the same as times 1 over the sine of 2x. And so now I see that I've got some sine values in there. Using a little bit of commutativity, I'm going to rearrange the way these numbers look. I'm going to leave my 3 in front and my cosine x in front. Now, this x I want to put over sine x, so I have times x over sine x. And this 2x, I'm going to put over my sine 2x. So I have times 2x over the sine of 2x. All right, and I'm going to use my reciprocal property one more time here. So I've got the limit as x goes to 0 of 3 cosine x times 1 over, I'll take the reciprocal of this, and that reciprocal is going to be sine x over x times 1 over, and again I'll take the reciprocal of this last piece, that would be sine 2x over 2x. Now, the limit of products is the product of the limits. The limit of quotients is the quotient of the limits, right? So I can break all of these into little pieces and look at evaluating them. And the good thing is I see that I have my sine x over x right here, which means this piece, when I plug in 0, I know that's going to equal 1. Now, sine 2x over 2x, that is similar to what we're looking for, but not exactly. However, if I am to come to this piece and I say, well, let theta equal 2x, then we would have sine theta over theta, right? So even though there's that coefficient 2 in there, it's still in the same form. So, if we look at this, plugging that in, I would have 3 times the cosine of 0. Cosine of 0, that's going to go to 1, times 1 over sine x divided by x. When I plug 0 into that, I know that gives me 1, times 1 over sine 2x over 2x is also going to give me 1. So in this situation, my limit value is 3 times 1 over 1 times 1 over 1, and that's just equal to 3. And I would like to consider one third example in this video. So for this example, we're going to do the limit as t approaches 0 of sine of 1 minus cosine t over 1 minus cosine t. So in that last example, we used substitution. And so you'll notice that this argument is the same as that. So essentially, it's like we have sine x over x or sine theta over theta, which is our goal. So we can do a substitution. I'm going to come over here and say, well, let's let theta equal 1 minus cosine of t. So that means we are dealing with a limit of sine of theta over theta. Now I've changed this limit, right? Originally, we were dealing with the limit as t goes to 0. So what is the limit as t goes to 0 of this argument? And if I were to plug 0 in here, I would get 1 minus the cosine of 0, or 1 minus 1, which is 0. So I can say, well, this is the same as saying that limit as theta approaches 0. Okay? And so in this case, we can say, all right, well, this would be equal by our theorem or our rule to 1. So I hope that helps. Just remember, sometimes you have to get creative with your manipulation and your factors. And it has to be sine theta over theta, or sine of whatever the argument is. That needs to be, that argument exactly needs to be in the denominator. So 1 minus cosine theta is the argument, 1 minus cosine theta is in the denominator.